For nearly 4 decades, 2 daring explorers have wandered through the vast expanse of space, pushing the frontiers of human understanding and reaching the outermost regions of our solar system. However, NASA is saying farewell to its legendary Voyager mission after an astounding 45-year trip. What could be the reason behind this? Is it true that NASA will terminate the historic Voyager mission? Prepare to be surprised. NASA is ending its iconic Voyager mission after 45 years. Now, in order to prolong the life of the Voyager probe's instruments, NASA turned them off over time. Following this, when each Voyager was launched with 10 different scientific instruments, Voyager 2 now has 5 operational instruments, whereas Voyager 1 only has 4. And this year, NASA plans to shut down some of the Voyager's still operational systems in the hopes of maintaining contact with them throughout their historic voyages until at least 2030. According to the Scientific American report, the decision to reduce power to a minimum was taken to extend the probe's lives for a few more years, with a soft cutoff date of 2030. Regarding the unusual endurance of the probes that were only intended to survive 4 short years, physicist Ralph McNutt of the Johns Hopkins University Applied Physics Laboratory noted in the study, "We've done 10 times the warranty on the darn things." According to the NASA representative to IE, the shutoffs have to happen because the onboard power supplies are decaying, reducing their output by 4 watts per year, so both spacecraft have less power to spend. This has been the case ever since launch, but after 45 years of flight, the power budget is getting to the point where the team has to turn off whatever they can to keep the spacecraft running and doing science. This is amazing, but not entirely unexpected. Both probes are fueled by radioactive plutonium reactors, which have kept a warm supply of electricity flowing to the small onboard computers, which have been running non-stop for decades. As the power supply depletes, an increasing number of components and gadgets must be turned off. During the early years of the Voyager missions, in 1977, Linda Spilker, a planetary scientist at JPL, said, "If everything goes really well, maybe we can get the missions extended into the 2030s. The power is all that matters. The limiting factor is there," Spilker continued. In her email to IE, Cofield also stated that the Voyager Science Steering Group will decide this August on the next steps for managing the power budget. The engineering team has come up with some innovative methods to keep both Voyagers performing as much science as they can for as long as they can. Currently, the farthest man-made objects in space are interstellar probes. However, their quest for the unexpected result got off to a rough start. All 4 of the major planets, Jupiter, Saturn, Uranus, and Neptune, aligned with Earth in a lengthy arc in the late 1970s and early 1980s, looking like pearls strung together in a necklace of the cosmos. Only once every 176 years does this alignment take place, making it the ideal time to deploy a spacecraft to investigate the outer planets. This is because in such an alignment, a spaceship may benefit from the gravitational pull of each big planet it passes through. If launched precisely by the mid-1970s, a spacecraft's journey duration between Earth and Neptune would have been lowered from 30 years to 12 years. To take advantage of this once-in-a-lifetime chance, NASA devised plans for a grand tour that would send up to 5 probes to the 4 large planets and Pluto. Although the idea was grandiose, it was also costly, and as a result, Congress rejected it. A scaled-down version of the project, initially known as Mariner Jupiter-Saturn 1977 or MJS-77, did receive approval from Congress. Only 2 planets were to receive spacecraft from this project. However, the engineers at NASA were optimistic. They created vehicles that could handle the challenges of a much longer expedition. They also hoped that if the twin probes proved themselves, their planned route would be extended to Uranus, Neptune, and beyond. Ultimately, Voyager 1 and Voyager 2 were launched within 15 days of one another in the summer of 1977, with a primary mission of 4 years, and were similar in every way. The rest is now in the past. Voyager 1, which had a different route and arrived in July of that year, followed Voyager 1, which had reached Jupiter in March 1979. Over 33,000 images of Jupiter and its satellites were captured by the Voyagers. The 3rd largest moon of the gas giant, Io, whose colorful appearance was utterly unexpected, provided some of the most stunning photographs captured by Voyagers during their approach to Jupiter. A moon with 10 times as much volcanic activity as Earth was a great surprise because, at the time, the only active volcanoes we were aware of existed on Earth. Following their exploration of the Jovian system, the spacecraft parted ways with Saturn, when Jupiter gave them a farewell kick of 35,700 miles per hour. Voyager 2 resumed its voyage to examine Uranus and Neptune, while Voyager 1 sped through Saturn's rings, past Titan, and eventually headed north out of the plane of the planets. Voyager 2 added Uranus to the growing list of ringed worlds in 1986 after discovering 10 additional moons orbiting the planet. How does NASA intend to carry out this mission? NASA is ending its iconic Voyager mission after 45 years with the intention to turn off the cameras on both spacecraft at some point after the 4-year grand tour was finished. This indicates that neither of the spacecraft would have taken any more photos after the ones of Neptune and its moons captured by Voyager 2. Carl Sagan, however, made a specific request at the time NASA was preparing to do so. He asked the authorities to order Voyager 1 to send one final batch of photos that pointed back at us. Voyager 1's cameras were turned backward at his request on February 14, 1990, at a distance of 4 billion miles. About 60 photos of the Sun and planets were taken by the spacecraft, providing the first outsider's perspective of our solar system. A picture of Earth that eventually gained fame as the pale blue dot was one of the images in the mosaic. This picture showed how small we are in relation to the universe by showing our blue planet as a tiny particle against a magnificent light beam. After taking this famous photograph, Voyagers embarked on an endless voyage into the unknown. Voyager 1 detected strong magnetic field intensities at a distance of 94 astronomical units on December 16, 2004. According to a scientific announcement, this demonstrated that the spacecraft had passed the termination shock and was now inside the heliosheath, where the solar wind suddenly slows, becoming thicker and hotter. Finally, Voyager 1 became the first spacecraft to leave the heliosphere and enter interstellar space on August 25, 2012. 6 years later, in December 2018, NASA revealed that Voyager 2 had reached interstellar space as well. Voyager spacecraft have now traveled further and endured longer than any other spacecraft in history. They are so far apart that a one-way radio communication traveling at the speed of light takes about 22 hours to reach Voyager 1 and slightly more than 18 hours to reach Voyager 2. Furthermore, they move away by 3 to 4 light seconds every day. However, the twins are still functioning. They transmit data to Earth on a daily basis from planets well beyond the solar system's most distant known worlds. They are the simplest yet most efficient, one-of-a-kind spaceship ever designed, since practically everything aboard was hardwired. They don't rely on thousands of lines of code to work, and they don't have microprocessors. All of the devices are powered by a mechanism that turns heat from plutonium's radioactive decay into electricity. However, with temperatures rapidly lowering, keeping the devices alive is tough. The mission engineers shut off the heater for the cosmic ray detector, which had played a critical role in determining the heliopause transit 2 years ago. Despite the fact that everyone expected the instrument to fail, it continued to function. The magnetometer and plasma science instrument, which are located in the spacecraft's body and are warmed by heat released by computers, will be turned off next. Click on the subscribe button if you are finding this video interesting. If everything goes well, we may be able to prolong the missions beyond the 2030s. However, everything is dependent on power. Even if the Voyagers are silenced, their voyages through space will continue. Voyager 1 is expected to approach our nearest neighboring star, Proxima Centauri, in another 16,700 years, followed by Voyager 2 3,600 years later. They will then continue to circle the galaxy for millions of years. They'll still be out there, more or less undamaged. And who knows, maybe one day they'll come into contact with another civilization and can communicate with them via the historic golden recordings on board. The golden records contain sights and sounds intended to convey a feel of the world from which the Voyagers originated. Pictures of children, dolphins, dancers, and sunsets are included, as are sounds of crickets, falling rain, and a mother kissing her child, as well as 90 minutes of music. Voyagers have altered our perception of the universe. Given that the missions were only supposed to last 4 years, they have well exceeded everyone's expectations. But the legendary spacecraft's time is running out, and one day they will drift out of reach of the deep space network, sinking into a sea of endless quiet. Do you consider the Voyager mission to be the most successful in history? Want to know more about Voyager 1 and 2? detected something beyond the edge of our solar system. Watch this video popping on the screen right now to learn more.